When you think about renewable energy, the first thing that comes to mind is unlimited resources. Sun. Many places on Earth receive a significant amount of sunlight throughout the day. According to Dr. Kinnell, the amount of sunlight received by Earth in 1 hour is more than the total energy used by the entire world for an entire year. This information sparked an idea, an architecturally revolutionary invention for Frank Walker: solar thermal collectors. Frank Walker developed a concept that converts sun rays into hot water, hot air, or air ventilation. Unlike solar panels, a collector of a solar thermal system does not consist of photovoltaic cells to generate electricity directly. A solar thermal panel is connected to a storage tank, a hot water tank for liquid system, or an enclosed room for air systems. Solar liquid systems may be passive or active. A passive system is one where the hot water tank is placed high up in the cycle to allow for gravity to circulate the water. A system that does not depend on gravity is active because a pump of some sort is required to distribute the water. This system is extremely sustainable, especially in locations that are limited on hot water, because it is essentially converting sun rays into heated water without a need for technology, such as PV. Likewise, air-based systems are both active and passive depending on the complexity, whether a fan is required or not. Air can be heated from the outside if indoor ventilation is needed, or air can be heated from the inside. Both liquid and air systems are based on heating, hence the name solar thermal systems. Just under 50 years have passed since the first solar thermal panels were installed on a building. Since then, they rose exponentially in popularity, adaptations have been made to suit various functions, and they have even started influencing architecture. One project that directly shows the effectiveness of a solar thermal system is a passive house design renovation in Brooklyn, New York. The Tite House was a brownstone home built in 1899 and resembled any other house in the neighborhood. Passive house design reconstructed parts of the house to make it as eco-friendly as possible. Now this residence consumes approximately 90% less heat energy than the average home and 70% less energy overall. Airtight insulation and natural light sources were added as passive strategies, but most importantly, the designers added a sloping roof of 21 degrees oriented along the north-south axis. This planned roof design and orientation is optimal for solar exposure. The Tite House features a combination of PV solar panels for energy and solar thermal collectors for air, heating, and ventilation. Achieving near zero energy waste and almost no active systems in the building, the Tite House received winner of the 2014 International Passive House Design Award. It is crucial to understand the power of a solar thermal system integration into architecture, as solar energy is not a finite resource, and this system will help not only save money, but also in the environment in the long run.